So, first of all, it's labeled postulates, and this lesson's primarily about postulates. What is a postulate? A postulate, or also known as an axiom. I haven't seen the word axiom in a long time, like on testing, so postulate's the main word that you need to know, is a statement that is accepted as true without proof. So its basic ideas about points, lines, and planes can be stated as postulates. You don't need to prove anything, it is what it is. And so we have a bunch of postulates here. There's 1, 2, 3, 4, 7 of them. It'll say postulate 2.1, postulate 2.2. These numbers aren't important. They just correspond to whatever textbook this came from. So depending on the textbook, those numbers change. So you don't really need to know the numbers. That doesn't make sense to even focus on. So we have a bunch of postulates here. It says the first one, through any 2 points, there is exactly one line going through them. So we have 2 points, point A and B, and through any 2 points, there is one line going through them like this. You've seen this before. It came up in chapter 1 as well, so if it feels like review, it is. So you can draw 2 points anywhere, and through any 2 points, there is exactly one line. Also think about it in 3D space. There could be a point on the board right here, and then a point on my desk, and I could draw a line through those 2 points. Okay, the next one is similar to that. A line contains at least 2 points. So if you're given 2 points, then it's a line, or if you're given a line, then you know that it has at least 2 points. Let's say this is point L and M. We could say that this is line LM. Okay, and then the next postulate, through any 3 non-collinear points. So non-collinear points are points that aren't in the same line. There is exactly one plane that contains them. So here's 3 non-collinear points, and through any 3 non-collinear points, there is one plane. And again, it doesn't have to be just like 2D space, it could be 3D, like a point on the desk, a point on the board, and a point on the floor, and I could draw a plane through those 3 points. Okay, then similar to that, a plane contains at least 3 non-collinear points. So 3 non-collinear points, like that. And next, if 2 points lie on a plane, so if 2 points, let's say L and M, lie on a plane, then the entire line containing those points lies on the plane. And the next one, 2 lines intersect. So 2 lines intersect at exactly 1 point. And then 2 planes intersect at exactly, 2 planes intersect at a line. 1 line. And remember, these planes go on forever and ever. They show them as rectangles because they're trying to like make it fit on paper, but realistically, it'd go on forever and ever. Okay, so once you're done, flip it over to the other side. Okay, then on this side, we have ruler postulate, which we've seen a little bit before. Every point on a line can be paired with a real number, and that's why we can measure stuff on a ruler. So this can paired with 2, and then this 5.5. So to find the length of this segment, we can do 5.5 minus 2, and it gives us 3.5 centimeters. And then we are going to bring in the word theorem. So a theorem, so we have postulate, which is just a statement that's already true. A theorem is a statement or conjecture that has been proven to be true. It can be used as a reason to justify statements in proofs. So a theorem is a statement that's already been proven. So for example, midpoint theorem. it says M is the midpoint of segment AB, then AM is congruent to MB. So AM is congruent to MB. And congruent means the exact same shape and size. When we say congruent, we could be talking about like pentagons with a lot of different congruent parts. With a segment, though, we're just talking about the length of that segment. So we can say that AM is equal to MB in length. So when you see it right here, it's just talking about the length of AM, and this is referring to the length of MB. Okay, so the next questions are similar to what you're going to see on homework. What we're going to do is to answer these, we're just going to use the postulates that we wrote down on the other page. So for the first one, it says, determine whether each statement is always, sometimes, or never true. It says line R contains only point P. Well, on the other page, we said that a line contains at least 2 points. So it can't just contain 1 point. So this would be never true. A line contains at least 2 points. And then the next one, through 2 points, there's exactly 1 line. Well, we literally have that right here. Through any 2 points, there is exactly 1 line going through them. So that is always true. Through 2 points is 1 line. Number 3, there's exactly 1 plane that contains non-collinear points A, B, C. That would be always. So over here, a plane contains at least 3 non-collinear points, or through any 3 non-collinear points, there's 1 plane. Through any 3 non-collinear points is 1 plane. I tried to abbreviate as much as I can. Number 4 is a sometimes. It says if points M, N, and P lie on plane Z, they are collinear. Well, they could be collinear, but they could also, I'm going to draw a picture. So this is sometimes. So I'm drawing 2 planes. It's saying they are collinear because they lie on the same plane. They could be collinear, but they could also be non-collinear and lie on the same plane. So and then number 5, the intersection of 2 planes can be a point. This one, the intersection, 2 planes intersect at exactly 1 line, not a point. So this is never. Planes intersect at a line. Okay, so 6 through 9, similar. It just says state the postulate that can be used to show each statement is true. It also gives you a picture over here too. For number 6, exactly 1 plane contains points F, B, and E. Well, any plane contains at least 3 non-collinear points. A plane contains at least 3 non-collinear points. Number 7, line BE. Well, they show points B and E, line BE lies on plane Q. So if we were to draw this line, yes, it lies on plane Q. And the reason is if 2 points lie on a plane, then the entire line containing those points lies on a plane. So if 2 points, trying to abbreviate, lie on a plane, then the line containing the points lies on the plane. So if 2 points lie on a plane, then the line containing the points lies on the plane. Okay, number 8. The intersection of FG and AC is point B. Yes, 2 lines intersect at a point. 2 lines intersect at a point. And again, that's just one of the postulates on the other page. And number 9, plane ABF and CDG intersect at line CD. Yes, 2 planes intersect at a line. Okay, so what we're going to do now, I'm sure list it out. Okay, so what you're going to do is you are going to post a video, and I'll show you how to do that, about one postulate that we learned today. And I'll show you 2 homework 3-4A on Schoology. And then start Alex, your weekly Alex. Okay, so as far as the video goes, I'll show you what to do, but you're going to use these and you're just going to choose one here. Let me turn this video off first.